Hi everyone. Today's lesson is on rational exponents. So what is a rational number? Remember, a rational number is basically any number that can be written as a fraction, okay? So we're looking at essentially exponents that are fractions or decimals, of course, that can be written as fractions. Okay, so what does it mean? You've actually technically done some of this stuff. It's just been written in a different form. So let's look at the rule here for a rational exponent. Rational exponent here. Basically, see how I have the n on the bottom there, x to the 1 over n? Well, the n is essentially just the root, the number of the root. So it's just like writing it like a square root, a cubed root, etc. So let's look at some of these. Some are pretty basic examples, like 49 to the 1/2. That is exactly the same as saying the square root of 49. Now remember, most of the time for most of our lives in math, we've never really even written that 2 there. So when we say a square root, we usually just wrote this symbol, right? But if you say the square root of 49, that's the same thing as saying the square root of 49 like that, or 49 to the 2nd root. So square roots are so common that people literally just, I think out of laziness, just stopped writing them. So if we don't see a number there, it's a 2. But of course we can have other roots other than 2. So when we say the square root of 49, obviously what we mean is what number times itself twice gives you 49. You don't have to write it out in this many steps. I'm just pointing out that the answer would be 7, because 7 times 7 is 49. So 49 to the power of 1/2 is 7. So again, essentially a square root, or a root, I really shouldn't say square because they're not all going to be square roots, but in this case it is, right, is the same as having it to the power of 1 over that root. Okay, so let's look at a few more here. -8 to the 1/3. So we can rewrite that as a root. So what that means is this, okay? Third root of -8, like that. These are the same thing. So when we evaluate it, it's usually easier to write it this way instead of leaving it as a fraction. Rewrite like that. So what number times itself 3 times equals -8? That's what it means, right? So you don't have to show the step, but I'm going to be doing it through all my work here just to think my way through. Oh, it would be, oops, not -3 times -3. What am I, -8 times -8? Sorry, I've recorded so many videos today. I'm just getting yours, and I think my brain's starting to peter out. There we go. -2 times -2 times -2, right? That's the number that times itself 3 times gives you -8. So the answer would be -2. So again, for some of you are wondering, hey, I thought you couldn't have a negative under square root. It's not a square root, right? It's the 3rd root. That's okay. We can have an odd number there, right? That's all right. But if it was even, like in the next case, we're going to run into a problem. So let me show you what I mean. If I say the 4th root, or -16 to the power of 1/4, or the 4th root of 16, we could rewrite it as a radical expression like this. And then what we're basically saying is what number times itself 4 times gives you -16? The answer is there is no real solution, right? No real solution, right? All right. So there's no real number that when you multiply itself 4 times will give you a negative number, right? It works with an odd number, but not with an even. So the thing we want to kind of maybe keep in mind is anytime we encounter this scenario where we have a root with an even number here, right, like 2 or 4 or 6, and a negative value under the bracket, that will always give us no real solution. So in this case, if you try and punch that in your calculator, -16 to the power of 1/4, it's not going to work. It's going to say error or something like that, math error. All right, so there we go. Now, the next one, let's check this one out. So now we're going to combine this new rule that we're learning about with one of our older rules. So remember the rule we've talked about, what do we do with a negative exponent, right? Well, the negative exponent causes the reciprocal of the original value. So in this case, I would rewrite this as 1 over 16 to the 1/4. And the reason I did that, let me fix that 4, is because of this negative right here, right? So that's the first rule we're going to apply. Now, I want the 16 to the 1/4 means the 4th root. Oh man, I just hate how my computer see how it keeps fixing. You've noticed probably over the last few weeks, it keeps making all my 4s and a 9s. All right, anyways, this 4th root of 16. So what number times itself 4 times gives you 16? Again, you don't have to do this little baby step here. It would be 2, right? Because 2 times 2 is 4, times 2 is 8, times 2 is 16. So 4 2's multiplied to make 16. So the answer would just be 1/2. All right, there we go. All right, last one. This one I'm putting everything together. I'm putting together some old rules, some new rules. I got a negative on the exponent. I got a negative on the base. Now, first thing, these two negatives do not cancel out. You can't just go, oh, cool, negative and negative, they cancel and I'm all done. No, that's not how it works, okay? So first, let's deal with the negative on the exponent. What does that mean? It means we need to take the reciprocal from our previous lessons. So this would be 1 over negative 64 to the 1/3. Oh, it's wrecking my 4s again. There we go. See, just every time. There we go. All right, so now I'm going to deal with the rational exponent, right? So that would be the 1/4. So now I've dealt with the negative. I'm going to say, all right, what number, right? We need to take the 4th root of negative 64. So what number times itself 4 times gives you, oh, now why did I make it a 4? It's supposed to be a 3. Sorry for those of you who are like, why is he writing a 4? I don't know, guys. There we go. It should be a 3. A 3. Because if I did the 4th root of 64, I was going to get a decimal. So that's when I realized I must have wrote the wrong number down here. All right, so what number times itself 3 times gives you negative 64? Well, negative 4 times negative 4 will give you positive 16 times a negative 4 will give you negative 64. So the answer is going to be 1 over negative 4. Now, don't leave a negative on the bottom of your fraction. So if you get a final answer ever with a negative, I don't care if you're in grade 9, grade 11, university, move that negative out front, okay? Just proper form. All right, so that would be the answer to that. Okay, so don't forget, the negative exponent causes the reciprocal. We don't cancel out with the exponent out front, okay? All right. So let's talk about, well, how do you do this in your calculator? Because all these you could evaluate in your calculator if you wanted, and it's important to be able to double check this. But for those of you who are going to continue in math, I know right now a lot of today's lesson, you might just go, oh, I can just punch all this in my calculator. I'll figure it out later. I'll learn it later. This is the time to learn this. You really have to know this stuff because when we get into heavier algebra, your calculator is not going to be able to solve it for you. So we're basically starting on numbers, simple numbers, things we can check on our calculator to make sure we understand. So take the time, take the, little bit of time to actually try these out and verify them with your calculator, okay? Now, if you're going to your calculator and I want to do, I got 7.6 of the 1/3. All right, I'm not going to figure out the exact value of that by hand, right? Again, what does this mean? This means the 3rd root of 7.6. So what number times itself 3 times gives you 7.6? So how are you going to punch this in your calculator? Well, you're basically going to hit 3 first, right? It depends. Most calculators, I shouldn't say all. My calculator, most of them, this is what you do. You hit 3, and then you generally have to hit the 2nd button. And you're looking for, it's usually hidden above this button here, or this button here. It's an X with a Y or a Y with an X. And above that button, you should see this symbol here. It generally looks like this. There's usually a little X there. It might be a Y, but it's usually an X above one of these buttons. All right, so let me pull up my computer calculator, which is not as good as the handheld ones. I got to get a better one installed one of these days. All right, so for this one, it's got the function hidden. It's probably above this one. See how I have an XY here? So if I hit 2nd, see how it changed it to Y there? That's it, right? See, it's a little different than this. They have it like this. They have a Y. They have it like that. Okay, so there we go. So you have to look for that. It's usually above one of the buttons, okay? So in this case, we'll have to see which order I punch it in. I think I hit the 3 first. Then I'm going to hit that. And then I'm going to hit 7.6. All right, no, I hit it in the wrong order. I know that's not the right answer. So let's switch this around. And that's every calculator I've ever used except for this computer calculator. For some reason on this one, I have to hit the opposite order. So in this one, I have to hit 7.6, then 2nd, that button, and then 3. There we go, 1.966, whatever, approximately, right? So we'll just say it's approximately 1.966. That'll do. Okay. So there's the approximate value. It keeps going, right? But there it is approximately. So play around with your calculator first. Get out your calculator. Even if you want to pause the video, go check it out. See how it works on your calculator so you know how to do these, right? And pick something even easier. Pick something like the 3rd power of 8. Like that's what I do. Do something simple because like the 3rd power of 8 is 2. So figure out which pattern of buttons to punch in. When do you punch the 3? When do you punch in the 8? So that gives you 2. So that way you understand how to use your calculator before you get into this homework, okay? All right. Let's check out a little more. Example, this is just kind of reversing things. Express as a power. So what if, in the first case, let me just move up here, right? I took these, they're already written as powers, and I wrote them as radical expressions, which means I'm using that root symbol, right? That radical symbol. Down here, I'm giving you them as radicals, and I want you to rewrite them as powers. So first of all, not because there's a 2 under here, but remember, if you don't see a number out front right here, this number is called the index, by the way. I should have mentioned that right off the bat. So if you don't see a number in the index position, okay, it's a 2. So that's the only one that's invisible. Everything else there should be something there. So if I want to rewrite this as a power, because sometimes we want to do work in the exponents, to combine things, to simplify things. So sometimes we actually want to go the opposite way and rewrite them. This would just be 2 to the 1/2. Same with this. This would be 36 to the 1/3. All right, now this one here would be 1/5 to the 1/3. And generally, we may want to, you'll find in some of your homework questions that you want to write this on top, right? Like I don't want this on the bottom in the denominator, I want it in the numerator. So what we can do is write it like this, right? By putting a negative on it. So now I've written it not on the denominator, but up in the numerator. Same with this one here. This would be 1/11 to the 1/4. And then again, what if I don't want that on the bottom? What if I want to move it to the numerator? I can just change the exponent from a positive to a negative, right? So these are little tricks, and again, a lot of people get confused, like, well, when do I do that? It's not a matter of like, oh, you have to do this every time. I'm trying to show you some little tricks where, hey, this might make it easier to do by rewriting it that way, okay? All right, so that's pretty quick. How do I reverse it? How do I write it as a power? Now, I want to look at this example here a little more closely. So notice how we could write it like that. I'm going to zero in on that one to kind of extrapolate and create the next rule or the next step in this rule. Okay, so let's look at 2 different ways of writing this thing. 36 to the 1/3. Well, 36 to the root 3, we already said in that example is 36 to the 1/3. But couldn't I rewrite 36 as 6 squared, right? So that means this would be 6 squared to the 1/3. Now, what is remember our power of a power rule? When we have a power of a power, we can multiply. So like when I have 2 to the 3 to the 5, I can make that 2 to the 15, right? Power of a power rule. So the same thing applies here. What I can do, leave the base as 6, and I can go 2 times 1/3 is 2/3. So I can write it like that. So another way of looking at this is, what if I take this? I want to take this a little bit further and kind of break this down. I'm just kind of jumping around back and forth to get used to how I can write this in different ways. So what if we take that 6 2/3? That means there are 2 kind of pieces of the puzzle going on here. The bottom number is the index of the root, right? So in other words, it's this right there. Remember, what if I put it's right there, right? What if I put that 3 right back where it was, right? And underneath would be 6 squared, right? So I could write it like that. Or I could even switch it around and do it like this. I could do the 3rd root of 6 first and then square it. Now this is a little more important than maybe it seems right now. I want to really kind of highlight this, what I've written right here. So what I'm trying to point out to you is look at the top number. The top number, the squared, right? 6 squared is 36, right? Isn't that where I got that 6 squared from to begin with, right? So that top number of the fraction is a regular exponent the way we're used to it, 6 squared, right? The bottom number, let me highlight that in green, is the index of the radical, right? So now there's 2 different ways you can write it. It depends on what you want to evaluate first. Do you want to do the squaring first and then do the 3rd root? Or do you want to do the 3rd root first and then square it? So notice in this case, I put it outside a set of brackets. These are both equivalent. We can write it 2 different ways. So that's the rule that we have right over here, okay? The rule says if you have an exponent on top and an exponent on the bottom, a numerator and denominator, right? Okay? The exponent on the numerator, you treat it like a regular exponent. So what you're pretty much used to at this point in your life and what you've been doing all this time. The bottom number is the index of the radical. So that tells us, what root we're supposed to be finding. All right, so I'm going to break down some of these and try to explain them and show you how we can evaluate them. We'll go through some basic examples and then a little more complex ones, okay? But this right here is a really, really, really important rule. We got to know that. So even if you rely on your calculator to do a lot of stuff, if you just skim through all this and you don't actually pay attention, you don't try the homework by hand, you're going to have a real tough time when the questions get a little more difficult, okay? So really, it's about the idea of breaking these down and finding different ways of breaking them down, not just punching out and getting an answer. That's where we're trying to develop a certain skill here, okay? Okay, so let's check out 4 examples here using that rule we just talked about. And again, instead of just punching our calculator, let's make sure we really understand how these work, okay? Because I could just go to my calculator and go, what's 25 to the power of 3 divided by 2? It'll spit out the answer. But then I'm not going to understand how to do the more difficult work and how to move forward. All I know is how to handle the basic stuff with a calculator. So this is less about getting the answer and more about developing your understanding, okay? All right, so let's check this out. So what does this really mean? This means you have the second root of 25. So I'm going to write it like this. The second root of the base, which is 25, to the power of, the top number is like a regular old exponent, 3. So what's the second root of 25? What number times itself twice gives you 25? Square root. It's 5, right? And then what's 5 to the power of 3? 5 times 5 times 5 is 125. Now that's one way of doing it. Let's look at a different way. So there's 2 ways, like I was showing you before. You could write it 2 different ways. In this case, what did I do first? First, I did the root, right, of the radical there. And then second, I did the regular exponent, right? Okay, so now what if we do it a different way? What if I did the regular exponent first and then the radical? So I could write it differently, and I'm going to get the same answer. So in other words, what if I wrote it like this? What if I did 25 to the power of 3 first, right? And then I took, I don't really need brackets there, I guess, and then I took the second root of that. Now here's where I'm in a little bit of trouble, because 25 to the power of 3, well, maybe I'm not, maybe you know how to do this. There are some shortcuts, but I go to my calculator and I go, all right, what's 25 to the power of 3? All right, 15, 625. All right. Oops, come on there. 15,625. And then what's the square root of that, right? So then I come along, I'm gonna do my square root, and I get 125. So it works. But the advantage of the first way was, notice how, what did I do first? I shrunk the number first. So by handling the radical on the bottom there, by handling this first, do you notice how I shrunk the number? Notice how I took that 25 and made it into 5? So generally, not all the time, but generally, if you're like, well, which way should I go? I would deal with this first. Because what that does is it shrinks the number, right? I didn't have to go to my calculator to figure out the square root of 25 is 5, and then 5 times 5 times 5 is 125. Where in this case, I did the top first, right? And I had to do 25 to the power of 3. So I made the number bigger, right? Where in this case, I shrunk it. So the tip is, why don't you do, again, not always, but it's a suggested shortcut, or suggested pathway to take, is deal with the bottom first. So let's do that in this one. Again, I could do it 2 different ways, but what if I deal with this first, right? What is the third root of -8? That's what that bottom means. And then square that. So all I'm really doing is rewriting the bottom, the denominator, as a radical. All right, well, the third root of -8, the number that times itself 3 times to give you -8 is -2. And then -2 squared is +4. There you go. Now I'll show you one last time on this, and then I'm just gonna always use the method I'm using in the first case, because it's a lot quicker. So, but if you wanted to go the other route, right? Okay, then you'd have to do, what is -8 squared first? You'd have to square it first, and notice I put brackets around the negative, and then do the third root of that. So you go, all right, well, -8 squared is not so bad, right? -8 squared is +64, and then you say, all right, what times itself 3 times gives you 64? We saw that earlier. The answer is 4. So I get the same answer, but I like this way better. This is better, okay? All right, let's do 81 to the 0.75. Again, without just jumping to my calculator, trying to develop my understanding. 0.75 is just 3/4, right? There you go. Fix that 4. All right, so what does that mean? I need to find the 4th root of 81 and then do that to the power of 3. So I always like to deal with the root first and then to the power of the exponent 3. All right, so the 4th root of 81 is 3, right? Because 3 times 3, let's think, 3 times 3 is 9. Times 3 is 27, times 3 is 81. So there you go. And then do that to the power of 3. 3 times 3 times 3 is 27. There you go. All right, one final one. This one I'm throwing everything at you, right? Now, first thing to look out for, I put a negative up top, right? So what does that mean? We need to determine the reciprocal of this, right? Reciprocal. There we go. So what does that essentially do? Well, if I'm applying a negative to that, he flips to the bottom. I'm applying a negative to the 8, it flips to the top. So all that ends up happening is we just flip this fraction, and we just get negative 8 over 1, which is just negative 8 to the 2/3. And now I get rid of that negative up there. Okay? And then this actually becomes the same as this question over here. They're the same thing now, right? Because look at that and that are exactly the same. This is just a different way of writing what we wrote over here. It's the same thing. So in other words, what's the third root of negative 8? And then square that, right? So the third root of negative 8 is negative 2. It's negative 2 times negative 2 times negative 2. 3 times, it's negative 8. And then negative 2 squared is positive 4. So there you go. Same answer. All right, so that was a quick intro to this. There's some good textbook stuff to check out. And check out the next lesson because it continues with this topic, but getting into more algebra examples.